Welcome. If you want to constrain the movement to any axis, while the gumball works excellently as long as it's along either the x-axis, the y-axis or the z-axis, if you, as an example, want to move this smaller box diagonally with regards to this larger box, then we can first initiate the move command with M, and then let's take this as a starting point, and then without clicking to confirm the end placement, we can simply hover here at the snapping points diagonally and press Tab on the keyboard. This highlights the line as you see here, and now the movement is constrained to the custom axis that you set. The sweep one or sweep along one rail command is very useful if you want to extrude along a curve. In this case we want to add these cornices to these boxes, and we already have the cross-section curve of the cornice, so what we need now is the rail. And extracting a rail from this top surface can be done in at least two ways. The first method is to select this object and enter the command extract wireframe. This will extract all of the edges for this object, and then with all of these selected, they are 45 curves, we can hold Ctrl to deselect those that we want to use as segments of a rail, these 4. Now we can delete the rest. If we type cell last, we will select the most recent selection set, of which there are only these 4 curves left. Let's do Ctrl J to join these into one closed curve. This was one way of achieving this. Another way, let's delete this, is to enter the command extract surface. And then we can, with copy set to yes, we can select this specific and space enter to confirm. And then we can duplicate the border of this with a dupe border. And now we have it already now. We also have one superfluous surface here that we can delete. With this curve selected, we can type sweep 1. And now we select the cross-section curve here and space enter to confirm and confirm the seam point there. And the default settings worked out very nicely. Here we have it. For this lower surface here, we may do the extract surface 1 and then dupe border and then do the sweep 1 with this one. And here we see that it continues, of course, inside the larger box here. But that is of no real consequences. We can very easily select this and do Boolean difference with this one. And here we have it. If you want to create a surface in between two rails with at least one cross-section line, you may use the sweep 2 command. Select any of the first 2 rails and the second, and now the cross-section curve or curves, and then space enter to confirm. Default settings worked out fine in this case. Very good. If you simply want to sweep along an axis, then you may use the revolve command. If we type revolve here, we can select the curves that we want to revolve around an axis. And then the start of the revolve axis in this case should be the bottom there. We'll use the center of the circle for the start of the axis, and then the end of the axis can be the end point here. And then to revolve all the way around, we simply confirm that the start angle is 0 and the revolution angle is 360, and we get the whole revolution. The Gumball tool is very nifty for easy transformations. One additional perk with the Gumball tool is that if you want to position the center point of the selected object at a certain point, then you may activate Snappy dragging. And that makes the Gumball tool, or rather the center of the object that is used with the Gumball tool, snap to any activated snapping points. After a series of Boolean operations, we clearly see that although the objects are joined into one closed solid poly surface, it is still constituted by the original sets of surfaces. If we want to join these surfaces not only as conjoined surfaces, but topologically uniform surfaces, then we may utilize the command MergeAllFaces. And in more recent versions of Rhino, it's MergeAllCoplanarFaces, because that is exactly what it does. If the surfaces are coplanar, then they are topologically rebuilt so as to consist of only one uniform surface per flat area. If one, for purely aesthetical reasons, want to further clean up the aesthetics of the surfaces in a shaded display mode, one may also scroll down here in the object properties and uncheck show surface isocurves. If one finds that one has accidentally or not bloated the scene with curves and wants to quickly select all of them for easy deletion or hiding them or placing them in a separate layer, then one may enter the command SelCrv. This will select all curves, which may then be promptly deleted, and we find ourselves with a more clean viewport. However, if one wants to remove only a selection of curves, then one may use the command selection filter to toggle a separate toolbar, as you saw here. where you can right mouse button click on curves, and now this makes any selection in the viewport only eligible for curves. So now we can remove the curves here for any reason while keeping the curves here. To reset the selection filter, one right mouse button clicks again. And if one has trouble resetting the toggling of these boxes, one may right mouse button click any of these, left mouse button click so that nothing is selected, and then right mouse button click twice, and then left again. Now everything is selected again. There are a multitude of variations on the cell commands, like we did previously with SelCrv. We have the option to select of most benefit to us, perhaps open polysurface, and we see that this is not closed, so we can cap this with the command cap, which will close any flat opening of any open objects. And escape to deselect, and then if we type cell open surface, we see that this is also open, so we can cap that as well. And now when we delete the curves and select everything with Ctrl A, we see that we have 3 closed solid polysurfaces ready for Boolean union. Very good. If we find ourselves with an arbitrarily rotated object with no straight corners to allow it to be easily rotated back to a state where its bottom surface is horizontal, one may use the command rotate 3D with a straight guidance geometry so as to make the bottom surface planar. The first thing we can do is to create a bounding box. This is to make sure that the helper geometry is strictly horizontal and with straight edges. We can make sure that the bounding box is selected and make sure to scale down this so that it only covers a small area of the bottom surface here. That is totally sufficient. Now we can do extract surface and extract this bottom surface, a duplicate copy of it, so to say. We can split this with this straight box. Now we have that there. We can hold Control to deselect the one that we want to keep and delete the rest. This one, we can actually do the same. We can do extract surface and extract the bottom surface. This is totally planar. With that extracted, we can delete the bounding box. Now we can move this object together with this guidance plane and move these to a corner where these two are co-aligned, and then we can rotate in 3 dimensions. That means that we define a custom rotational axis. So the first one may be any of the 2, of course, but we can do this one from that corner to this one. And now rotating this, it should be from this corner to that corner. And now we do the same for the other axis. So space or enter to do the same command again. Let's start with this one and make sure that this is the axis. And then we rotate from that to there. Now this bottom surface is strictly coplanar to the horizontal XY plane. We may verify this. We can actually delete these, optimistic as we are, and then do a bounding box. And we see here that the border of the bottom surface, all of it is co-aligned to the perfectly flat bounding box bottom surface. Very good. When one has worked with a plan drawing in 2D and want to see how it looks in 3D, one fairly quick and easy way to go from these sets of singular lines, signifying the placement of window openings, since they are not boundaries, one cannot easily make surfaces out of them, but there is a fairly quick way forward. If one selects all of the curves intended to be used as input and then type the command hatch. By default, a hatch is made in the same way as a planar surface would be made, simply discarding the lines for window openings. But if one selects this option here, boundary, one may, at their own leisure, select where they want the void to be filled with solid, so to say. So then one traverses around the building and selects where there should be solid, and then space or enter to confirm. Now press OK to confirm, and SelLast will select the most recently generated selection set, which is these hatches. Hatches can be very easily exploded into surfaces, and now we are practically done. If we go to perspective and zoom to select, and then we can extrude these surfaces, perhaps 1200 upwards, and then we may select the boundaries of the wall, so to say, and do a planar surface out of that. Select last to select that, and do an extrusion negative 1000. And then we may actually copy this, lock the movements to the vertical axis with V, and then move it to here. And then we can select last, select that one, scale 1D, and then scale this to perhaps 450. And then we can take this exterior facade curve again and do a planar surface with it covering the hole, so to say, and select last and move that with snappy dragging to the top here and extrude that 450 perhaps. And then we can do one final with this curve and planar surface and select last. Move this down to the floor, so to say, and do it negative 350. a fairly quick and easy way to create a 3-dimensional representation of your plan drawing. And we can create a box there to there and go down to there, and then we select this one and Boolean difference with this one and delete that one. If one is in the process of preparing a vector drawing for laser cutting or any other process where duplicate objects are a hassle or straight out problematic, one may be relieved that if one discovers that, oh no, there are actually 4 duplicate curves for each and every intended curve, then we may use the command SelDup. This will select all duplicate objects, excluding 1 unique per duplicate. So in this case, immediately after SelDup, if we delete the selection, then we find that for each and every one of these, which there were 4 copies of, now there are only 1. Very good. This concludes this tutorial. Thank you for your time.